along x-axis with its position x varying with time as this, the ratio of its initial velocity to its initial acceleration. So x is this, so therefore dx by dt, which is velocity, is going to be 4 alpha t cube plus 2 beta t plus gamma. So what we have done is, so dx to the power n by dt is equal to n into x to the power n minus 1. So therefore d t to the power 4 by dt is equal to 4t cube, and so on. So therefore velocity at 0 is equal to initial velocity, it's equal to gamma. Now we differentiate velocity, so we get dv by dt, which is equal to acceleration, that is 12 alpha t square plus 2 beta. So therefore acceleration at time t equal to 0 is equal to 2 beta. So therefore ratio of initial velocity to initial acceleration is gamma upon 2 beta, which is the option number D. Thank you. The velocity time plot of the motion of a body is shown. The acceleration time graph that best suits this motion is. So we can see here that from t is equal to 0 to this time, let us say t1, the velocity is 0 and the velocity is constant, so therefore the acceleration is 0 here. Now from t1 to this, so this line, we can see that the velocity is continuously increasing, and the slope of the velocity time graph, because it is a straight line, so therefore the slope is going to be constant, so therefore here acceleration is positive and it is constant. Here acceleration is equal to 0 because as time is progressing velocity is constant, so therefore there is no change in velocity, dv is 0, so therefore dv by dt is also going to be 0. And towards the end, since the velocity is decreasing at a constant rate, so therefore the acceleration is again negative, and since the slope is same, since it is straight line, so it's negative constant. So again, so acceleration is 0 here, positive constant here, 0 here, negative constant. So 0, this is positive constant, 0 and negative constant. Okay, here you see acceleration is increasing, so wrong. Here again acceleration is increasing, wrong. Here again acceleration is increasing, so wrong. So therefore B is going to be the answer. Fine. The position of a particle is given by 4t I cap plus 2t square j cap plus 5k cap, where t is in seconds, r is in meters. Find magnitude and direction of velocity at t equals 1 second. So the velocity is going to be dr by dt, which is 4 I cap plus 4t j cap plus, since this is constant, so therefore differentiation is going to be 0. So 4t's differentiation is 4, 2t's differentiation is 4t, as d by dt x to the power n is equal to n x to the power n minus 1. So it was t square, so therefore d by dt of t square is going to be 2t, and d by dt of t is going to be 1. So that's why we have written like this. So therefore the velocity at 1 second is going to be 4 I cap plus 4 j cap. The magnitude becomes root over 4 square plus 4 square, which is 4 root 2 meter per second, and the theta, so tan theta is equal to 4 by 4, so therefore theta is equal to 45 degree with respect to x axis. So therefore C is the option. Thank you. A football player is moving southward and suddenly turns eastward with the same speed to avoid an opponent. So is moving southward and he suddenly turns eastward. Okay, because this is east, north, west and south. Okay, the force that acts on the player while turning is, so we can write the velocity initial is equal to minus j cap, velocity final is equal to I cap. So therefore dv, which is change in velocity, that is delta v, which is final velocity minus initial velocity, is equal to I cap minus of minus j cap, which is equal to I cap plus j cap. Now since acceleration is equal to dv by dt, so therefore so the direction of dv is going to determine the acceleration. So that is I cap plus j cap, that means the acceleration is towards this, so therefore the force is towards this. Okay, so this is along north east, so therefore D is the option. A vehicle travels half the distance with speed v. So let us say this is the distance. So half, that is d by 2, it travels with speed v, and the remaining distance with 2v. So we have to find the average speed. So we can tell the time taken is equal to d by 2v in this case, and the time taken in this case is going to be d by 2 into 1 by 2v, which is d by 4v. So therefore the average is going to be the total distance traveled, which is d, divided by the total time taken, d by 2v plus d by 4v, which is equal to 1, because d is getting cancelled. So 1 by 2 plus 1 by 4, which is 1 divided by 3 by 4, which is 4 by 3. Okay, and of course v is there, so v will also go up, so 4 by 3 v. So therefore D is going to be the answer. So here what we have done is basically we added this, so 4v 2 plus 1, so that's why it becomes 1 divided by 3 by 4. So therefore D is the answer. A bullet from a gun is fired in a rectangular wooden block with velocity u. When bullet travels 24 cm through the block along its length horizontally, velocity of the bullet becomes u by 3. So this is u, and u by 3 it becomes in a span of 24 cm. So therefore we write v square equals u square plus 2as. So of course when it is penetrating the wooden block, the wooden block is resisting its motion, so therefore the acceleration is in this direction, which is negative. So therefore v square final velocity u by 3 whole square is equal to u square minus 2 into a into 24 centimeter. So this becomes u square by 9 minus u square is equal to minus 2 into a into 24 centimeter. So therefore 8 by 9 u square is equal to 2 into a into 24 centimeter. That is first equation. Now then it further penetrates in the block in the same direction before coming to rest. So now it's u by 3, and then it penetrates and it comes to rest. So let it be s, and here the velocity is 0. So again using the same equation, so final velocity is 0 square. This is equal to initial velocity u by 3 whole square minus 2 into a into s. So therefore u square by 9 is equal to 2 into a into s. Now u square by 9 was 2. Okay, so here we can do this. So u square by 9 is 2 into a into 3 centimeter. Okay, so 2a, u square by 9 is 2a into, so therefore we can write 2 into a into 3 centimeter is equal to 2 into a into s. 2a is gone, so therefore the s is equal to 3 centimeter. So further it is going to go 3 centimeter. So therefore the total length of the block is going to be, so already 24 centimeter it had traveled. Now 3 centimeter more it is going to go. So therefore the total is 24 plus 3, which is 27 centimeter. Thank you. The horizontal bridge is built across a river. So this is the bridge. Student standing on it throws a ball vertically up with a velocity of 4 meter per second. So this is u. The ball strikes the water surface after 4 seconds. So u is equal to 4 meter per second, time is equal to 4 seconds, and acceleration due to gravity g. So a is going to be minus 10 meter per second square. So therefore s is equal to ut plus half at a square, 4 into 4 plus half into a minus 10 into 4 into 4, 16 to 16 minus 80, which is minus 64 meters. So therefore the ball is going to go like this and is going to go down and hit the surface of the water. Okay, and this height is 64 meters. Okay, so therefore D is going to be the answer. The position time graph for positive acceleration is, so if you see, so the acceleration is positive, that means velocity is increasing. Now what is velocity? Velocity is the slope of xt graph. So the slope of xt graph must be increasing. So here the slope, if you see, this is positive, and here the slope has become more positive. Okay, and it is increased. So therefore in this option, yes, velocity is increasing. In this option the velocity is constant because the slope is constant. Here velocity's slope is decreasing, so here acceleration is negative, and here since xt is same, so therefore velocity is 0. So therefore only option is A. Thank you. The ratio of the distances traveled by a freely falling body in the first, second, third and the fourth second. So for the freely falling body we have s is equal to ut plus half at square. So let us say the initial velocity is 0. So therefore s becomes simply half into a into t square. Now s of 1 is going to be half of a into 1. So in 1 second that much has been traveled. In 2 seconds half into a into 2 square, which is 4. Half into a into 9, and s4 is equal to half into a into 16. So therefore in the first second how much it is traveled? A by 2. In the second second how much is traveled? So this minus this, so half into a into 3. In the third second, so this is first second, this is second second, this is the third second, the difference between this, So half into a into 9 minus 4, which is half into a into 5. And in the fourth second, it's going to be the difference between this, half into a into 16 minus 9, which is half into a into 7. So therefore the ratio is going to be 1:3:5:7. That is B. Thank you. The displacement time graphs of two moving particles make angles of 30° and 45° with the x-axis as shown in the figure. The ratio of the respective body. So for the body which is moving, which is having 30°, so basically the velocity is equal to tan 30°, as velocity is the slope of xt graph. So tan 30° is equal to 1/√3. And for 45°, the velocity is going to be tan 45°, which is equal to 1. So therefore the ratio of the respective velocity is 1/√3 divided by 1, which is equal to 1/√3 itself. So therefore C is going to be the answer. A small block slides down a smooth inclined plane. So this is a smooth inclined plane. So in a smooth inclined plane, this is mg. So this is theta. So this is theta. So this becomes mg cos theta, and this becomes mg sin theta, and this is the normal. So how this is, how the theta is there. So we see here, this is mg and this is theta. So this is going to be 90 minus theta. So this is going to be theta. So therefore in this direction there is mg cos theta. Now in y direction, like the perpendicular to the plane, it's going to be n is equal to mg cos theta. But since it is frictionless, so therefore along the plane, the only force which is there is mg sin theta. So therefore in this direction the acceleration is equal to mg sin theta divided by m, which is equal to g sin theta. So now Sn be the distance traveled by the block in the interval t equals n minus 1 to t equals n. Then the ratio Sn by Sn plus 1 is equal to. So of course we can write, because it is there is only g sin theta is a constant acceleration case. So therefore we can write S of n plus 1 is equal to half into g into n plus 1 whole square. Sn is equal to half into g into n square. So we are using this formula, S equals ut plus half gt square. Okay, now here of course g has a sin theta component also, which is multiplied with it. Okay, and S of n minus 1 is equal to half of g sin theta into n minus 1 whole square. Now Sn by Sn plus 1. So Sn is the distance traveled from n minus 1 to n. So therefore half g sin theta into n square minus n minus 1 whole square. This is Sn. Okay, because till nth second it is here, till n minus 1 it was here. So therefore the difference between them is Sn. Now here for n plus 1, it's going to be half g sin theta into n plus 1 whole square minus n square. These both are gone. So therefore it becomes n minus n minus 1 into n plus n minus 1 divided by n plus 1 minus n into n plus 1 plus n. We have used the formula a square minus b square is equal to a plus b into a minus b. So this is, so n minus n plus 1. So this is 1. this is also 1, so therefore this is 2n minus 1 divided by 2n plus 1. So therefore C is going to be the answer. Thank you. A car starts from rest and accelerates at 5 meter per second square. Okay, so this is acceleration as 5 meter per second square. So t equals 4 second. So therefore velocity at 4 second is going to be u plus at. Initial velocity was 0 as it was at rest. So therefore 0 plus a, which is 5, into time is 4. So this is 20 meter per second. And this is in the horizontal direction. So 20 meter per second velocity is in the horizontal direction. Now what is the velocity and acceleration of the ball at t equals 6 seconds? So that means after 2 seconds. So now it is after 2 seconds, this dropped out of a window by a person sitting. So at t equals 6 seconds, okay, so that means after 2 seconds. So after 2 seconds the velocity in this direction will remain as 20 only. Okay, this is the velocity in x, but velocity in y will be 0 plus gt, which is 10 into 2, which will become again 20 meter per second. So this was the condition, 20 in this direction, 20 in this direction. So therefore the net velocity is going to be 20 root 2 meter per second. And the acceleration of the ball will be downwards 10 meter per second square, because now it will be a free fall. There is mg acting and there is no other force than mg, so that will cause the acceleration to be 10 meter per second square. So therefore C is going to be the option. Thank you.
On the floor of an elevator drops a coin. The coin reaches the floor in time t1 if the elevator is at rest. So let us say this is the condition where the elevator is at rest. So this is height h and the coin is dropped. So since the coin is dropped, so therefore we can write this equation that half, initial velocity is 0, so half into g t1 square is equal to h. So therefore t1 becomes root over 2h by g. Okay, so this is t1. And in time t2, if the elevator is moving uniformly, now let us say the elevator is moving uniformly with a speed u. So therefore in time t2, okay, and now the coin is dropped. So in time t2 the elevator has went up by how much? U into t2, and the coin has went up by, now the coin is also dropped. So now the coin's position is not this. The coin should be resting on the ground after time t2. So therefore this coin has went up how much? U into t2 minus half into g t2 square. Okay, because the coin is also having initial velocity as u and the acceleration due to gravity is g. Now this is the height h. So this should be equal to, if you see, so from here to here it is u t2, so there from here to, so therefore h, so this is u t2, okay, and minus h. So this much should be the distance which the coin has went up. So u t2 minus h. So u t2 gets cancelled. So here also h becomes equal to half g t2 square So therefore the t2 is again root 2 h by g. So therefore D option is correct. Thank you. A person traveling in a straight line moves with a constant velocity v1 for certain distance x. So this x and the velocity is v1. So therefore time taken is equal to x by v1. And with a constant velocity v2 for the next equal distance. So the next equal distance x, the velocity is v2. So therefore the time taken is equal to x by v2. So this is t1, this is t2. The average velocity is, so velocity average is going to be total distance or displacement divided by total time taken, which is equal to 2x divided by the time taken, which is x by v1 plus x by v2. Okay, so this is v average. So now x is gone, so therefore we take this to this side. So 1 by v1 plus 1 by v2 is equal to 2 upon v average. So therefore B is going to be the answer. A toy car with charge q moves on a frictionless horizontal plane surface under the influence of a uniform electric field E. Okay, so this is a toy car and it is moving with, so therefore the force q is applied to it and its velocity increases from 0 to 6 meter per second in 1 second. So therefore the acceleration is equal to 6 meter per second minus 0 divided by 1 second, which is 6 meter per second square. So this is the acceleration. The car continues to move for 2. At that instance the direction of the field is reversed. Okay, so that means the acceleration at graph is going to be 6 and then minus 6 and continues to move for 2 more seconds under the influence of the field. So this is minus 6. So this is from 0 to 1 and this is from 1 to 3. Now under this the velocity time graph is going to be like so this is velocity time graph. So from 0 it became to 6 and then from 6 it becomes to 0. This is 1 second, 2 second and this is the 3rd second. Okay, so it will go to minus 6. Okay, the average velocity and the average speed of the car. Okay, so if we see here, then the displacement is equal to the area under the VT curve. So therefore half into base into height, this is plus, and minus half into 1 into 6 minus 3, so this is equal to 3 meters. So this is the total displacement which has occurred. Now this area was 6, this area was 3, so therefore total distance is 9 meters. Time taken is 3 seconds, so therefore this is the average velocity, which is 1 meter per second, whereas the distance is 9 meters, so therefore the average speed is 3 meter per second. So therefore B is going to be the answer. Thank you. Preeti reached the metro station and found the escalator is not working. She walked up the stationary escalator in time t1. So let us say, so this is the escalator and therefore then let us say the distance going to be covered is d, so that that much distance has to be covered. So she walked up the stationary escalator, so let the speed of Preeti be u1. Okay, so therefore d by u1 is equal to t1, and when the escalator is moving, so let us say the moving escalator has the speed u2, so therefore d by u2 is equal to t2. Okay, the time taken by her to walk up on the moving escalator, so now both the speeds are going to add up. So now the question is d by u1 plus u2 is equal to how much? Okay. So u1 is equal to d by t1. So we write here this is equal to how much? So d by u1. Okay. So u1 is equal to d by t1 and u2 is equal to d by t2. So t1 into t2 divided by t1 plus t2 is going to be the answer, because now d gets cancelled. So this reduces to 1 by t1 plus 1 by t2. Take both of them common, so, and this goes up, so therefore this is going to be the answer. X and y coordinates. So x is equal to 5t minus 2t square. So therefore dx by dt, which is velocity, is equal to 5 minus 4t, and acceleration, which is equal to dv by dt, is equal to minus 4. Now y is equal to 10t, so therefore velocity in y direction is equal to dy by dt, which is equal to 10, and acceleration in y direction is equal to the differentiation of this, which is 0. So this is acceleration in x direction, velocity in x direction. So therefore the acceleration of the particle at t equals 2 seconds. Since acceleration is constant as minus 4, so therefore the answer is going to be minus 4. It doesn't change as time changes. Thank you. Two cars P and Q start from a point at the same time in a straight line, and their positions are represented by this. At what time do the cars have the same velocity? So velocity of P is going to be d of xp by dt, which is equal to a plus 2bt. Velocity of q is going to be d of xq by dt, which is equal to f minus 2t. So now they should have same velocity, so therefore a plus 2bt should be equal to f minus 2t. That means 2b plus 2 into t should be f minus a. So therefore the time taken is going to be f minus a divided by 2b plus 1, which is the D option. Thank you. A particle moves so that its position is given by r equals cos omega t plus sin omega t, where omega is a constant. So if you see this, okay, let us say the particle starts from here and it is moving with an angular velocity of omega, so therefore this is going to be omega t. Okay, so x coordinate is cos omega t and y coordinate is sin omega t. Okay, so that means this is basically a circular motion, because from the origin the particle is always at a distance of 1. Okay, so we calculate the distance from the origin, which is equal to cos square omega t plus sin square omega t, and that is 1. Okay, so therefore it is a case of a circular motion. So when it is the case of circular motion, what is going to happen? So this is the radius vector or the position vector, and this is becomes the velocity vector, and this is the acceleration vector. So velocity and acceleration both are perpendicular to r. No, that's wrong. Both are parallel. That is also wrong. Velocity is perpendicular to r. This is correct. And acceleration is directed towards the origin. That is also correct. Velocity is perpendicular to r and acceleration directed away from the origin. That is wrong. It is directed towards the origin because of the centripetal acceleration. Okay, so therefore the option C is going to be correct. The velocity of the particle is u equals at plus bt square, where a and b are constant. Distance traveled by it between 1 second and 2 seconds is. So the velocity is given by at plus bt square. So therefore velocity is dx by dt, okay, which is equal to this. So therefore dx is equal to at plus bt square into dt. And now we have to find from 1 to 2. So this is going to be a into t square by 2 plus b into t cube by 3 from 1 to 2, which is equal to a by 2 into 4 minus 1 plus b by 3 into 2 cube minus 1, which is a by 2 into 3 plus b by 3 into 7. So 3a by 2 plus 7a by 3, that is C option. Thank you. The position vector of a particle r as a function of time is given by r equals 4 sine 2 pi t I cap plus 4 cos 2 pi t j cap. So in this case, if you see, the particle is actually starting from here and it's moving with a velocity of omega. So therefore if you see, so this is the x coordinate and this is the y coordinate. Now this is theta, which is omega t. So x and y coordinates, we can see here that the x coordinate becomes, okay, so this is r. So y coordinate is r cos omega t and x coordinate is r sine omega t. So this is the scenario, and as you can see that this position, okay, is if you see from the origin, if we calculate the distance from the origin, which is x minus 0 whole square plus y minus 0 whole square, so this is equal to root over r square sine square omega t plus cos square omega t. Of course the omega here is 2 pi, okay, so this becomes 1. So this is, so therefore this is r. So since the distance from the origin is fixed, okay, in this case, which is r, which is equal to 4, so therefore the particle is undergoing circular motion. So now since it is undergoing circular motion, therefore the magnitude of acceleration vector is going to be v square by r. That's true. So a part is going to be true. The magnitude is going to be 8 meter per second. That has to be found out, okay. So this is r. So therefore we have velocity vector is equal to dr by dt, which is equal to 4 into 2 pi cos 2 pi t I cap plus 4 into 2 pi minus sine 2 pi t j cap. So therefore the magnitude is going to be 4 into 2 pi, which is 8 pi meter per second. So it is not 8 meter per second. This is wrong. Okay, this is right. The third one, patch. No, it's not patch, it's path. Path of the particle is a circle of radius 4 meter. Yes, as we have seen this here. Okay, so the distance from the center, okay, it's going to be
4. So therefore yes, it is 4. This is wrong. Acceleration vector is along minus r. So this is the r vector, and acceleration is going to be in this direction because it is a centripetal acceleration which is directed towards the center. So yes, it's going to be along minus r. So r vector is this, minus r is this. So yes, this is also true. So therefore now the question is, which of the following statements is wrong for the motion of the particle? So therefore the B option is wrong. Okay, A and B, A, C are correct. So therefore we have to take the B option. Thank you. Two particles A and B move with constant velocities v1 and v2. So this is particle A, which is having a velocity v1 vector, and this is particle B, which is having a velocity, let us say, v2 vector. At the initial moment their position vectors are r1. So let us say this is the origin. So this is r1 vector, and this is r2 vector. The condition for the particles A and B for their collision is, so you see, collision is going to happen when the relative velocity of, we can do this in terms of A also or B also. So of A we are doing in terms of with respect to B. The relative velocity of A with respect to B is along the direction of, so basically A is going to see B. Okay, so so here B is going to see A. So relative velocity of A with respect to B, so that means velocity of A with respect to B is equal to VA minus VB, and in this case it's V1 minus V2 vector. Now this should be along this line joining A and B. Okay, it should be along the direction of AB. So now this is the velocity AB. Okay, so the direction of VAB, okay, so direction of VAB, so I'm writing here VAB cap, that's the direction, unit vector in the direction of VAB, should be equal to position of, okay, so this, now this vector is this AB vector, so should be AB cap, okay, in this direction. So therefore now what is VAB? V1 minus V2 vector by mod V1 minus V2 should be equal to, AB is R1 minus, no, it's R2 minus R1, R2 minus R1, okay, because AB vector is going to be OB vector minus OA vector, so R2 vector minus R1 vector divided by mod of R2 minus R1. So therefore the option number D is going to be the correct. Okay, I repeat it again. Collision is going to happen when the direction of the relative velocity of A with respect to B is going to be along AB, the initial line joining them. Thank you. A ship A is moving westwards with a speed 10 km per hour. So this is ship A and it is moving westwards 10. A ship B, which is 100 km south of A, this is B, and this distance is 100 kilometers. is moving northwards with a speed of 10 km per hour. This is moving northwards with a speed of 10. The time after which the distance between them becomes the shortest is. Okay. So if you see, let us find out velocity of B with respect to A, which is going to be VB minus VA, which is 10. See, this B vector is basically 10 j cap, and this A vector is basically minus 10 I cap. So therefore 10 j cap plus 10 I cap, which is equal to 10 of I cap plus j cap. So therefore velocity of B with respect to A is going to be in this direction. Okay. Which is 45 degrees. Now this is 100 kilometers. So therefore, if we kind of so this is 45 degrees, so this is also 45 degrees, and this is 100. So therefore this is 100 divided by root 2, which is 50 root 2 kilometers. And what is the velocity? The velocity's magnitude is 10 root 2 kilometer per hour, because it's 10 root 1 square plus 1 square. So now the distance which has to be traveled is 50 root 2 kilometer. Velocity is 10 root 2 kilometer per hour. Gone. So this is 5 hours. Therefore B is going to be the option. A particle undergoes one-dimensional motion such that its velocity varies as this. Where beta and n are constants and x is the position of the particle. The acceleration of the particle is a function x is given by. So acceleration is equal to dv upon dt. So therefore beta into, okay, so let us differentiate this. This is minus 2n x to the power minus 2n minus 1 into dx by dt. Now dx by dt is velocity only. So therefore beta into minus 2n x to the power minus 2n minus 1 into beta x to the power minus 2n, which is equal to minus 2n beta square x to the power minus 4n minus 1. So therefore B is going to be the answer. The particle is moving so that its position coordinates x, y are 2 meter 3 2, 3 at t equals 0, 6, 7 at time t equals 2, and 13, 14 at time t equals 5 seconds. The average velocity vector t equals 0 to t equals 5 seconds. So the position, okay, so what is the displacement? The displacement vector from t is equal to 0 to t is equal to 5 seconds. This is going to be 13 I cap minus 2 I cap plus 14 j cap minus 3 j cap, which is going to be 11 I cap plus 11 j cap. So this is the total displacement. So therefore we have velocity average vector is going to be the total displacement divided by total time taken, which is equal to 11 I cap plus 11 j cap divided by the time taken is 5 seconds. So therefore D option is going to be the answer. The displacement x of a particle of mass m moving in one dimension and the action of a force is related to this. So T is equal to root x plus 3. The displacement of the particle when the velocity will be 0. So we have root x is equal to t minus 3, and this x becomes t minus 3 whole square. Velocity is 0, so therefore dx by dt if we do, so it's 2 into t minus 3. So this is the velocity. So when velocity is 0, so that means 2 into t minus 3 is equal to 0, so that means t is equal to 3 seconds. Okay, so now that's velocity. Now acceleration, the displacement of the particle when velocity is 0. So the displacement is given by this equation here. Now it's mentioned that x is the displacement. So therefore the displacement at t equals to 3, so x at t equals to 3 is 3 minus 3 whole square, which is basically 0. So therefore B option is going to be correct. A stone falls freely under gravity. It's falling freely. So u is equal to 0 and acceleration is equal to g, because we are considering downwards to be positive. It covers distances h1, h2 and h3 in the first 5 seconds, next 5. Okay, so the displacement till 5th is going to be half into g into 5 square, 10th half into g into 10 square, and 15 it's going to be half into g into 15 whole square. Now h1 is going to be, let us consider, so s0 at time t equal to 0, it's 0 meters. So h1 is s5 minus s0, okay, which is half into g into 5 square. Now how we are writing this? Because see, when the particle is falling, okay, so this is s0, this is after 5 seconds, this is after 10 seconds, and this is after 15 seconds, like that. So therefore this, which is the distance traveled in the first 5 seconds, is going to be s5 minus s0. Distance traveled in the next 5 seconds is going to be s10 minus s5, which is half into g to 10 square minus 5 square, okay, which is half into g into 100 minus 25, which is 75. Here it's half into g into 25, and h3 becomes s15 minus s10, which is half into g into 15 square minus 10 square. So this is 225 minus 100, which is half into g into 125. So therefore we can see that h3 by 5 is equal to h2 by 3, which is equal to h1. So therefore B option is going to be the correct. A particle has initial velocity as 2 I cap plus 3 j cap, and the acceleration is 0.3 I cap plus 0.2 j cap. The magnitude of the velocity after 10 seconds will be. So we can clearly see that this is the velocity, initial velocity, acceleration is also constant. So let us see for x direction. So we have v is equal to u plus a into t. For convenience we just add this x. So velocity in x direction at time t is going to be ux plus axt. So therefore velocity in x direction after 10 seconds is going to be ux, which is 2, plus ax, which is 0.3 into 10, which is 5 meter per second. And for y direction, it's going to be vy is equal to uy plus ay into t. So that means velocity in y direction 10 seconds is going to be uy. So velocity in y direction is 3 plus ay, which is 0.2 into 10, which is again 5 meter per second. So therefore the magnitude of velocity after 10 seconds is going to be root over 5 square plus 5 square, which is 5 root 2 meter per second. That's going to be B is the answer. The motion of a particle along a straight line is described by this: x is equal to 8 plus 12t minus t cube. The x is in meters and t is in seconds. The retardation of the particle when its velocity becomes 0. So velocity is dx by dt, which is equal to 12 minus 3t square. This should be 0. So that means 3t square minus 12 should be 0. T square minus 4 should be equal to 0. So therefore t is equal to plus 2 second or minus 2 second. Of course this is neglected. At plus 2 seconds we have to find out acceleration. So now acceleration, which is equal to dv by dt, will be equal to minus 6t. Now t is 2 seconds when the velocity becomes 0. So therefore minus 6 into 2 is minus 12 meter per second square. Okay. So therefore the retardation is 12. D is the answer. A stone is dropped from a height h. Okay, a stone is dropped. It hits the ground with a certain momentum p. So let us say the mass is m of the stone and it is dropped. That means initial velocity is equal to 0. So here what is the final velocity? So final velocity is going to be half mv square is equal to mgh by the conservation of energy. M gone. So therefore velocity is going to be root over 2gh. So therefore the momentum is going to be m root 2gh, with which it is hitting the ground. If the same stone is dropped from a height 100% more than the previous height, so now h becomes 2h. The momentum when it hits the ground will change by, so now the momentum is going to be m root over 2g into 2h, which is m root over 4gh, which is basically root 2 into m root 2gh, which was the previous momentum. P, like old. This is P old. So now root 2 is basically 1.41. So the new momentum is going to be 1.41 times the old momentum. So therefore the momentum when it hits the ground will change by, so it has changed by 0.41. Okay, so basically P new minus P old. So this is 0.41 P old, which is the change is actually around 41%. So therefore B is going to be the answer. Thank you. A boy standing at the top of a tower of height 20 meters drops a stone. Stone is going down. Assuming g equals 10 meter per second square, the velocity with which it hits the ground is equal to, so of course half mv square is equal to mgh, mm gone. So the velocity becomes root over 2gh. So root over 2 into 10 into height, which was again 20. So this is 20 meter per second. So therefore the answer is going to be a body is moving with velocity 30 meter per second towards east. So 30 I cap. After 10 seconds its velocity becomes 40 towards south, towards north, 40 j cap. The average acceleration of the body is, so average acceleration is going to be the total change in velocity divided by the total time taken, which is equal to, now what is the change in velocity? So this is velocity final and this is the velocity initial. So Vf minus Vi. So this is 40 j cap minus 30 I cap divided by 10. Gone. Basically this is 4 j cap minus 3 I cap, and if you want to find out the magnitude, it's going to be root over 4 square plus 3 square, which is 5 meter per second square. So therefore the answer is going to be C. A ball is dropped from a high rise platform at t is equal to 0. Okay, so this is the ball and this is going below, starts from rest. Okay, and after 6 seconds another ball is thrown downwards from the same speed with a speed v. So here the speed is v and this is thrown after 6 seconds. So that means if suppose both of them they are going to meet here, this ball has traveled for t seconds but this ball has traveled only for t minus 6 seconds. So therefore now for this the initial velocity was 0. For this the initial velocity is v. So therefore the distance traveled is going to be half into g into t square, and here it's going to be vt plus half into g into t square. Okay, but here it's t1 and this t1 is t minus 6. So we'll equate both of them. So half into 10 into 18 square, because it's mentioned that they are meeting after 18 seconds, should be equal to v into t minus 6. So 18 minus 6 is 12 plus half into again 10 into t minus 6 whole square, which is 12 into 12. So therefore this is 5, this is also 5, 12, and this becomes 1.5. So v becomes 18 into 7.5 minus 60. So therefore 18 into 7.5 minus 60 is, this is 18 7 is 126. So 126 plus 9, which is 135. 135 minus 60 is 75. So therefore this is almost 75. So 74 meter per second is the answer. Particle moves a distance x and time t according to the equation this. So x is equal to 1 by t plus 5. So therefore velocity becomes minus 1 by t plus 5 whole square. So how we have found out? So v is equal to dx by dt, which is equal to d of 1 by t plus 5 by d of t plus 5 into d of t plus 5 by dt. This is the chain rule. So here we get, so d of z to the power n divided by dz is equal to n z to the power n minus 1. So Here it's t plus 5 to the power minus 1. So therefore minus 1 into t plus 5 minus 1 into this is 1. Differentiation of this is going to be 1. So therefore minus 1 by t plus 5 whole square. So this is velocity. So therefore t plus 5 is equal to minus 1 by root v, which is minus v to the power minus 1 by 2. Now acceleration is equal to minus of, so n is minus 2 here, so this becomes minus 2 into t plus 5 minus 2 minus 1. So this is 2 by t plus 5 whole cube. Okay, so this is 2 by t plus 5 is this, so we have to cube it. So minus v to the power minus 3 by 2, which is minus 2 v to the power 3 by 2, because minus it goes up, so therefore it becomes v to the power 3 by 2. So therefore since it is proportional to v to the power 3 by 2, so therefore A is going to be the answer. Thank you. A bus is moving with a speed of 10 meter per second on a straight road. Okay, so bus is moving with a velocity of 10 meter per second on a straight road. Scooterist wishes to overtake the bus in 100 seconds. Now the scooter is here and the time is going to be 100 seconds. If the bus is at a distance of 1000 meters, which is 1 kilometer, with what speed should the scooterist chase the bus? So here there is no acceleration basically, so therefore let the velocity be v. So therefore the velocity of a scooterist with respect to bus becomes velocity of scooterist minus velocity of bus, which is v minus 10 into 100. This should be equal to 1000. So into 100 seconds should be equal to 1000 meters. Gone. So this is 10. So v should be equal to 20 meter per second. So therefore A is the answer. A particle starts its motion from rest under the action of a constant force. So if the force is constant, so therefore the acceleration is also constant, because acceleration is equal to force divided by mass. If the distance covered in the first 10 seconds is s1, so like it is started from rest, t is equal to 0. In t is equal to 10 seconds, it has covered half into a into t square, which is half into a into 100. At t equals 20 seconds, it has covered half a into 20 whole square, which is half into a into 400, which is 200a here, and here it is 50a. Okay, so therefore the distance covered in 10 seconds, first 10 seconds is 50a. The distance covered in the first 20 seconds is 200a. Okay, so this is s2, this is s1, so s2 equals 4s1. C is the answer. The distance traveled by a particle starting from rest and moving with an acceleration in the third second is, so till third second it has covered half into 4 by 3 into 3 into 3, half 80 square. Till 2 seconds it has covered half into 4 by 3 into 2 into 2. So therefore in the third second it has covered half into 4 by 3 into 9 minus 4, which is half into 4 by 3 into 5, which is gone 2, which is 10 by 3 meters. So therefore C is going to be the answer. The particle shows distance time curve as given in the figure. Maximum instantaneous velocity of the particle is around the point. So the velocity is going to be the slope of this curve. Okay, so we see at A the slope is going to be like this. So the slope is basically tan theta. So now as theta progresses, increases, of course less than pi by 2, the slope is going to be more. At B it's going to be something like this. At C, yes, at C is really, high, and at D it's going to be like this. So therefore just we have to compare the slope, and as we can clearly see that at C the slope is the greatest, so therefore the answer will be C. Thank you. A particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meter per second to 20 meter per second while passing through a distance 135 meter in t seconds. The value of t is. Okay. So, when a particle is traveling with constant acceleration, we can write s is equal to u plus v by 2 into t. Okay, so therefore s is 135, this is equal to u, which is 10, plus v, which is 20, divided by 2 into time. So therefore, this is 30 plus 2, this is 15, 30 divided by 2, 15. So therefore t is equal to 135 by 15, which is 9 seconds. So therefore the answer is 9 seconds. The position x of a particle with respect to time along x-axis is given by this. So x is equal to 9 t square minus t cube, where x is in meters and t is in seconds. What will be the position of this particle when it achieves maximum speed along the x direction? So velocity is going to be equal to dx by dt, which is 18t minus 3t square, which is 3t, 6 minus t. Okay, so this is, so the velocity is basically something like this. T is equal to 0, t is equal to 6, and the velocity is going to be like this. Okay, because this is a parabola. Okay, and this is having the roots at 0 and 6. Since the a is negative, so therefore it is facing downwards, and thus here we have at t equals 3 seconds, we have the maximum velocity or speed. Okay, so what will the position of this particle when it achieves maximum speed along this? So here we have to just put t equals to 3. So x is equal to 9 into 3 square minus 3 cube. So 81 minus 27, which is going to be equal to 54 meters. Therefore a is going to be the answer. A car moves from x to y with a uniform speed vu. So let the distance be d, so therefore the time taken is going to be d divided by vu, and then from y to x with a uniform speed of vd. So here the time taken is going to be d by vd. So therefore the average speed is going to be d plus d divided by the total time, which is d by vu plus d by vd. 2d divided by d, vu plus vd, vu into vd, gone. So this is 2 into vu into vd divided by vu plus vd. So therefore d is going to be the option. A particle moving along the x-axis has acceleration f at time t given by, so this is f is equal to f naught 1 minus t by t, where f naught and t are constants. The particle at t equals 0 has 0 velocity. The time interval between t equals 0 and the instance when f equals 0, the particle's velocity vx is So this is acceleration. Okay, now acceleration is dv upon dt. So we can write dv, so this is acceleration, so therefore dv is equal to f dt, which is f naught 1 minus t by t into dt. Now at time t equal to 0, velocity is 0. So at time t equals to t, velocity is, we can find out by the integration. So f naught t minus t square by 2t. So this is the velocity which is there at time t. So in the time interval between t equal to 0 and the instance when f is equal to 0. So now when f is equal to 0, so f naught 1 minus t by t should be equal to 0. So therefore 1 minus t by t is equal to 0. So therefore t should be equal to t. So therefore this velocity is equal to v naught, f naught, sorry, t minus t square by 2t, gone. So this is f naught into t by 2. So therefore C is going to be the answer. A particle moves along a straight line OX at time t seconds. In seconds, the distance of the particle from O is given by this. How long did the particle travel before coming to rest? So this is x is equal to 40 plus 12t minus t cube. So velocity is equal to dx by dt, which is equal to 12 minus 3t square. Okay, which is 4 minus t square. So of course the velocity is 0 at t is equal to 2 seconds. Now this is the diagram of velocity. Okay, from so this is 0 to 2. Okay, and of course it's 12 meter per second here. Now we can see that in the entire time from 0 to 2 seconds, velocity is positive. So that means the particle has traveled in positive x direction only. So therefore the distance and the displacement is going to be the same, because there is no reversal of displacement, or in another sense, the velocity time graph and even the speed time graph are going to be same, because the speed time graph is mod of velocity time graph. Okay, so therefore what we can do is we can just find out at x is at t equal to 0, x is 40, and at t equals to 2, the position is 40 plus 12 into 2 minus 2 cube, which is 40 plus 24, 64 minus 8, which is 56 meters. Okay, so now how long would the particle travel before coming to rest? So at 0 it's at 40 meters, at 2 seconds is 56 meters, so therefore it has traveled 16 meters. So therefore A is going to be the answer. Thank you. Two bodies, A of mass 1 kg and B of mass 3 kg, are dropped from heights of 16 meter and 25 meter respectively. So this is A, which is dropped from a height of 16 meters. Now since it is dropped, so therefore initial velocity is 0. So therefore half into g into t square is 16. Let us take it as t1. For B, the height is 25 meters. So therefore half into g into t2 square is equal to 25. Ratio of the time taken. So therefore t1 by t2 is equal to, okay, so root of 16 divided by root of 25, because these two is going to be cancelled anyway, so this is 4 by 5. So therefore the answer is A. A ball is thrown vertically up, okay, it has a speed of 10 meter per second. When it has reached 1/2 of its maximum height, how high does the ball rise? Okay, good. So let us say, it is thrown with a speed of u. Okay, so what is the maximum height reached? So we do this: v square equals u square plus 2 into a into s. Final velocity here is going to be 0. U square, we are taking this as positive, minus 2 into g into s, which is the maximum height. So u is going to be root over 2gs. Okay, the height is s. Now when it is at half of its maximum height, the speed is 10 meters per second. Okay, so we can do this. So v, that is, again we do v square equals u square plus 2 into a into s. Now here the final velocity is 10, so 10 into 10 is equal to u square plus 2 into minus g, and here s becomes s by 2. Okay, so this is 100 is equal to u square minus g into s. Now u square is 2gs, so therefore we write u square is equal to 2gs minus gs, which is equal to gs. So therefore s is equal to 100 divided by g, which is 100 divided by 10, which is 10 meters. So therefore the maximum height is 10 meters. A. The displacement x of a particle varies with time t as this. So x is equal to a e to the power minus at plus b to the power beta x. The velocity of the particle will be, so v is equal to dx by dt, so which is minus a into a to the power a e to the power minus at plus b to the power beta x into ln b. Okay, so the velocity of the particle will be, and all these are positive constants. Okay, so that is velocity. Now acceleration, if we have to find out, we do it dv by dt, which is a cube e to the power minus at plus b into ln b whole square, and this is beta x. Of course there may be some divided by beta also, so divided by beta square. Now we see acceleration is always positive, okay, because this is always positive and this is always positive. So therefore the velocity of the particle will go on increasing with time because the acceleration is positive. If a ball is thrown vertically with a speed u, the distance covered during the last t seconds of its ascent is, okay, So let us say what is the time taken for ascent. Okay, so v is equal to u plus at. So 0 is equal to u minus gt. So therefore time taken is u by g. This is the time taken for ascent. Now what we have to find out is the distance traveled, okay, during the last t seconds of ascent. So distance traveled during the last, so therefore this is at t ascent and t ascent minus t. Okay, so let us find out. So distance the at t ascent, okay, the height which is reached is equal to u square by 2 into g. How we did this? By v square equals u square plus 2 into as. Final velocity is 0, so therefore u square minus 2 into g into the height, this is equal to 0. So therefore h is equal to u square by 2g. Okay, this is done. Now at time t ascent minus t, it's going to be u t ascent. What is the time ascent? U by g minus t plus half at square plus half into a minus g into t square, which is again u by g minus t whole square. Okay, so this is h, and here it is h at time t ascent minus t. This is the height at t ascent. So this is going to be u square by g minus ut minus g by 2 into u square by g square minus 2 u by g into t plus t square. Okay, so we have u square by g minus ut minus u square by 2g plus, this becomes g is gone, 2 is gone, plus ut, and this is minus half gt square. So this is gone, and this becomes u square by 2g minus half gt square. So now this is h1. So what we have to find out? H minus, okay, h1. This is h1. So h minus h1 becomes u square by 2g minus u square by 2g plus half gt square. Gone. So therefore this is gt square by 2. So therefore B is going to be the answer. We can also find this by the velocity time graph. So velocity time graph, it's going to be something like this. Okay, so it started with an initial velocity u, and at time t of ascent it reaches a velocity 0. The last t seconds, so that means this is the t, and the slope we know it's g. So therefore this is basically g into t. Okay, this is t. So therefore the area which gives us the displacement is going to be half into t into gt, which is gt square by 2. Thank you. A man throws balls with the same speed vertically upwards, one after the other, at an interval of 2 seconds. What should be the speed of the throw so that more than 2 balls are in the sky at any time? So interval is 2 seconds. Okay, so that means, so this is the first ball which is thrown, it's in air. Then the second ball is thrown. The first ball has already traveled 2 seconds. and then this is the third ball which is thrown, so therefore the first ball has already traveled 4 seconds. Okay, and till the time the third ball is thrown, okay, so more than 2 balls, so at least the third ball should be in the air, so therefore the first ball should travel for more than 4 seconds. First ball must be in the air for more than 4 seconds. So therefore what is the time of flight? So it is 2 into u by g should be greater than 4. So u should be greater than 4g by 2, gone 2. So this is greater than 19.6 meter per second. Therefore A is going to be the answer. An object of mass 3 kg is at rest. A force is applied. The velocity of the object at t equals 3 seconds. So force. So therefore the acceleration is going to be F by m, which is 6t square by 3 I cap plus 4t by 3 j cap. Gone, this is 2. Now the initial velocity is 0, 0 in both x and y. So now we have to find the velocity. So let us first find it in the x direction. So dvx by dt is going to be 2t square. So therefore dvx is equal to 2t square dt. We integrate it. So from t is equal to 0, the velocity was 0. At t equals 3 seconds, we are finding velocity at x. So therefore this is going to be 2 into t cube by 3, which is 2 into 3 cube by 3 square. So this becomes 18 I cap. In y direction, velocity, now the acceleration is going to be 4t by 3. So therefore dvy is equal to 4t by 3 into dt, and we integrate it. Velocity 0, velocity y, from 0 to 3 seconds. So therefore the velocity y is going to be 4 by 3 into t square by 2, which is 4 by 3 into 1 by 2 into 3 into 3, gone 2 into 3, which is 6. So 6 j cap. So therefore the answer is going to be B.